Hello, everyone. Thank you very much for joining. Today, we're going to talk to you a little bit about OSIsoft 2014. So first, and a quick overview of the agenda. We're going to spend a few minutes talking about PyServer basics, and these are for the benefits of those of you on the phone who may be new to OSIsoft and the PyServer. And then we're going to spend a couple minutes talking about tags versus assets. And the goal of this section is to give you an idea as to the direction that OSIsoft is going with our software and some of the benefits that we anticipate you be able to receive from moving from a tag-centric world to an asset-centric world. And lastly, we're going to talk a little bit about the new analytics engine that we're providing in PyServer 2014 and go over some of the things that you can do with it, and follow that with a quick video, a 2-minute video of an example application that you can do with the new analytics engine. So with that, we're going to spend maybe 3 or 4 minutes talking about some basics of the PyServer, again, for the benefits of for those of you who are new to OSIsoft and the PyServer. So for many of you, and I hope all of you, you have some assets that are generating data. And these assets can be anything from something as simple as a valve or a pump to something a lot more complicated, like maybe a gas turbine, or maybe even a moving asset like a truck. All these assets, they generate data, and our goal, and hopefully that's the same goal as yours, is to make this data available to the data consumers. So who are the data consumers? Data consumers could be a process engineer trying to optimize a process, or maybe someone in an office who's trying to build a report for some KPIs or some roll-ups so that the pertinent information can be shown or can be given to someone who's interested in an overall view of your processes and on your plan. In between these data sources and the data consumers is where OSIsoft and the PyServer sits. We view ourselves as being in the space between the data source and the consumers, and we provide an infrastructure for all your data. So what does that really mean? So here's an example. Let's say you are a process engineer and you are responsible for pumps. And so you have a lot of pumps that you're looking after, and you want to do some real-time troubleshooting because there may be an issue with your pump. So how does that all work? So you got some pumps. The pumps are generating data, and you want to be able to store these time series data in such a way that you can do your real-time troubleshooting. So at OSIsoft, we provide many different interfaces that can take the data being generated by your assets and put them as time series data into the PyServer. Now, when the data goes into the PyServer, it's stored in a machine-friendly way in the PyData archive. Once the data is in the data archive, there are lots of things that you can do with it. From a human perspective, you want to interact your data using an asset-centric manner, which we'll go over in a few minutes. And you have a lot of data, and you want to be able to mark important events that pertains to your data. And you may want to apply some analytics on top. And more importantly, when something of interest happens, you want the pertinent people be notified. So all of this as a whole is what we call the PyServer today. Now, you have all this data, you have stored it. Now, how do the data consumers consume the data. OSIsoft provides several user tools. Some of you may be familiar with these. For example, PyCoreSite, Web Parts, Processable, and Data Lake. Well, that's all good. So now you have a data source, you have a data storage medium, you have contextualization tools, and you got user tools. You may have more than just pumps. You may have motors, actuators, other data sources. The suite of interfaces that OSIsoft provides can gather all this data and put all of them into the Pi server at one single place, thereby allowing all your data consumers, whether it be a process engineer or a maintenance person, to consume all this data. Now, OSIsoft concentrates on providing the data infrastructure for your data. Very often, the data consumers require specific applications that may leverage the data that's available in the Pi server. We provide a rich set of data access tools to allow third parties to build custom applications. We have a very rich partner ecosystem that can take the data that's available in the Pi server and layer application-specific software on top. Now, the Pi system is in many industries. Here's a short list of some of the major industries that we're in. As you can see, we're very strong in the power industry and oil and gas, but we're also used quite prevalently in other businesses like pulp and paper, chemical, and petrochemical industries. Well, after all, this webinar is about Pi Server 2014. So let's talk a little bit about Pi Server 2014 specifically. Some of you attending this webinar may be an existing OSIsoft customer, and you may have had your Pi server for a long time. So for some of you, you may know that in the past, the name Pi server is used was used as a way to describe the data archive. Well, the Pi server today has evolved. Pi server today is not just a data archive, which is, of course, it continues to have. It's a data storage for your time series data. But we also provide now a way for you to organize, provide context to your data, and organize it in such a way that's easy for you to find. Some of you may be aware that Pi Asset Framework is now part of the Pi server. In addition to the storage of time series data and PiAF, the Pi server today includes Pi event frames, which is a way for you to mark important events within your process, and also Pi notification, which is a way to notify users of specific events that may be happening to your data. We're also providing several different analytics that is now part of the Pi server, including performance equations, ACE, totalizers, and also asset-based analytics, which I'll get to in a few minutes, which is completely brand new in 2014. Of course, with a Pi server that is now much richer in function, we give you a way to manage your Pi server with system management tools and a few interfaces for system management. So in short, the Pi server is no longer just a time series data historian, but rather a package of many different features and functions that really completes what a Pi server was designed to do. So having said that, Let's spend a few minutes talking about tags versus assets. So for many of you, you may be experienced in the process industry. You may have started your career working with control systems. As you know, when you're working with a control system, every piece of data in a control system is a control system point of one form or another. So historically, when you work with this kind of data, you're really in a world what we call a tag-centric world. Your everyday job centers around specific points and tags. Now, there's nothing wrong with this. In some ways, you may even consider this to be a little bit more simple. However, at OSIsoft, over the last few years, we are marching towards an asset-centric world, and we're encouraging our users to take this journey with us. So what does that really mean? What that means is that we're encouraging our users to think of their data not as control system points, but rather properties that are associated with assets. And these assets can be logical ones, or it could be physical assets. And to that end, we're providing tools like Pi Asset Framework, or AF, to allow you to organize your assets in a hierarchy, via categories, or a handful of other ways so that your data is much easier to organize and for your users to find the pertinent information that's interesting to him. We are spending a lot of effort in the notion of templates so that information, once templatized, enforce in terms of their consistency, and also makes our client tools much richer in being able to compare and contrast different instances of the same asset that were derived from the same template. So here's a concrete example. Let's say you worked at a manufacturing plant or maybe an oil and gas installation, and you have some power generation equipment on site. So what you see on the screen here are a representation of some of these assets and the properties that are associated with these assets. As you can see in the middle of the slide, we have these properties that are written in such a way that are humanly consumable and that is consistent throughout the asset structure. So as an example, it's much easier for the users to understand compressor discharge pressure as opposed to a control system point name that no one seems to remember. Now, once you have built these asset representation inside the Pi system, now you can organize it in a logical manner. It could be, you can organize it, say, for example, based on geography, or you can organize them based on connectivity of these assets, and maybe even process flow. So in this way, you don't need to rely on that one person who may have been with the company for 30 years, and he's the only person that knows anything about a particular measurement, and he's retiring next week. So you're going to lose all that expertise with him leaving the company, but rather instead you can embed all that knowledge into a logical and understandable asset structure within your Pi system. So as you can see, as you will see in a few minutes, Pi Server 2014 has many features, especially the analytics engine, the new analytics engine, that relies on having assets in your Pi system. Now, that doesn't mean that the traditional strong points of the Pi server where it is an awesome time series data historian with 400 plus interfaces, those properties still remain. But PyServer today has grown. Now we give you tools to work with your data in an asset-centric manner, and by doing so, it really adds to your Pi system infrastructure. So moving forward, we at OSIsoft are going to concentrate on improving our existing products and also building and releasing new software products that are based on assets. So here on the screen, you see a URL to our external-facing Pi system roadmap, which gives you a look ahead, roughly 12 months, of the new products that are being worked on that's coming down the pipe. And we also, within the Pi system roadmap, gives you a look back as to some of the previous releases. So as an example, we are working on a new type of interface, or what we traditionally call interfaces, and we're calling them connectors. So what are connectors? Connectors are basically the next generation interface that not only brings the data into the Pi server from the data sources, it also automatically creates the pipe tags and also the AF assets for the AF objects for the particular assets that you're connecting the Pi connectors to. Another example would be integrators. Integrators are ways for us to take data out of the Pi server and put that data into a foreign system. A good example would be the Pi integrator for Esri ArcGIS. Many of you may have Esri products at your plant. That's a geolocation mapping software. And with the Pi integrator for Esri ArcGIS, you'll be able to integrate your Esri data with time series data from the Pi server. So these are some of the example exciting new technologies and new software that we have in the pipeline we're going to start releasing them over the next, say, 3 to 12 months. So by all means, if you're interested in seeing what we're working on, please visit this Pi system roadmap on the web. Okay, so having said that, let's talk a little bit about what's new in Pi Server 2014. The major feature that we're providing in Pi Server 2014 is a new high-performance analytics engine. And since this new analytics engine works completely based on assets, for now we're calling it asset-based analytics. So what are some of the key benefits of the new analytics engine? Well, first of all, we put in a lot of effort to make sure that it's very easy to use. So easy that some of our customers are saying that it really empowers the users to build their own calculations without involving a system administrator or some developer or expert. Everything can be templatized, which encourages standardization and reuse so that everyone's looking at the same thing and you don't have 99 people looking at one thing and then one person looking at something different. We put in a lot of effort to ensure that the calculation results and also the calculations themselves can easily be rolled up and turned into KPIs. And I'll show you an example of that shortly. So, automatic event logging. For many of our users, it's much more advantageous for them to look at their data and to work with their data in terms of important events as opposed to specific data points. So an event could be, for example, the startup of a big compressor, or maybe it is a shutdown event, or maybe it's a downtime event. So we put in some features into the new analytics engines to allow you to mark these important events in your data and for you to retrieve this data based on specific events. And lastly, we put in a lot of effort to ensure that from a performance and scalability standpoint, that it matches up with our customer expectations and what the rest of the Pi server can do. So what do we mean by performance and scalability? One of the key features is that we added new remote procedure calls, or RPCs, into the Pi server so that now we are able to retrieve data from the Pi server in bulk as opposed to having to go get data one at a time. For many of our customers, especially when they're trying to do aggregation or when they're trying to build reports, they require a large amount of data from the data archive, and they need that over a long period of time. So in the past, you would have to go to the data archive one tag at a time and retrieve one value at a time, or one tag at a time over a single time range. And now, with the performance improvements in some of the key underlying subsystems in the Pi server, we can do that in a much more efficient manner. So here's an example. Let's say you had to make a call to the data archive to retrieve one bit of information. Now that one call takes a certain amount of time. Relatively speaking, you will spend most of your time in network latency. The server itself is very efficient, and it would provide that bit of information to you in a very efficient manner. But latency would take up the majority of the time. Now, if you have to make two calls serially, one after another, what happens is it will take twice as long as one call. That's just physics. So how do we improve on that? Perhaps we can improve it by allowing you to retrieve 2 bits of information in one call in bulk. Now, it will take a slightly more time than one call, but not by a lot. This benefit gets even larger when your data set gets much bigger. So as an example, relatively speaking, today you can make 100 calls in bulk in less time than making 2 single calls in serial. So this is the type of thought process and improvement that we have put into the underlying subsystems in the Pi server to ensure that we have the performance from a data access perspective to feed the new calculation engine. In addition to the bulk call, we also added a new data pipe and also a new data cache so that, again, we can feed data fast enough to the new calculation engine so that it's not sitting idle. The new calculation engine, when we built it, we had some key usage scenarios in mind. The most important one that we went after is described here. So let's say you have a piece of asset. In this particular example is a boiler feed pump. You, as a process engineer, you may want to do some calculations based on the real-time data originating from this boiler feed pump. maybe you want to calculate the pump curve. Now, when you apply these calculations, the first thing you would want to do would be to test it to ensure that your calculations are correct. After testing it and you feel that the calculations are correct, you're going to want to schedule it. When I say schedule, I mean you can have the calculations run at a set time interval, or you may want the calculations to run when you get a new piece of data. Once the calculation starts running, you want to store the results into the Pi server, either as time series data or as events. When you design and build these new calculations, oftentimes you're going to want to apply these calculations to historical data that you have in your system. We call this backfilling, and backfilling is one of the key features that we built into version 1 of this new calculation engine. Now, of course, all this is based on assets. Therefore, we can leverage the template capabilities in Pi Asset Framework to ensure that these calculations are the same for every instance of similar assets from the same template. What that means is that if you make a change to these calculations, those changes will be propagated to all the templated instances. And then, of course, you can do a bulk backfill if you need to. Lastly, you don't only have one piece of asset, you have several pieces of similar assets. With the importance of generating reports and KPIs and such, the whole notion of roll-ups is one of the key features that we put into the calculation engine. So with that, I have a 2-minute video here to kind of give you a demonstration as to what the new calculation engine can do for you. So what you see here on the screen is the configuration user interface to AF, known as Pi System Explorer. And in this particular example, you have an asset hierarchy from an oil and gas installation, which happens to have some power generation equipment. In this case, your power generation equipment consists of gas turbines and steam turbines and so on. So to pick an example, let's say you have a gas turbine, and at the back end of this gas turbine, you have some temperature measurement probes. And one of the things that you want to do is you want to make sure that temperature measurements out of the back end of the gas turbine are all within a reasonable deviation from each other, because otherwise you probably have a hot spot in the output stages of your gas turbine, and that's a bad thing. So let's start this video quickly, and what this video is going to do is going to show you is how to build a set of calculations that looks at the average of the temperature measurements and then the deviation from the average. And as you will see, it's quite simple to build these calculations using the new calculation engine. So you start out at the template level. You want to give it a name. You want to apply it to a particular gas turbine. And as you start typing, the software helps you along. It tells you what's available, what you can use. There are functions that are available to you to apply. And once you build your calculation engine, you can go ahead and evaluate it. And what that does is it will give you a real-time, instantaneous calculation based on the equation that you just built. So far, in the last 15 seconds or so, what this video has shown is that you can build a simple equation using built-in functions and attributes in your AF structure, and then evaluate that equation to produce a number that hopefully will make sense to you. Now, you might want to go ahead and schedule this calculation. And in this case, we want to schedule it for event trigger, meaning every time I get a new value, I'm going to calculate. I want to store the result. It's important for me to keep track of the results that are calculated every time I get a new value. AF supports units of measure conversions, so you can go ahead and create the analysis so that when the results are written, it is written in the proper unit of measure. Now, because we built this at the template level, and I have 2 gas turbines, that one equation would be applied to both instances of the gas turbine, as you would see in this video. As you can see, the output is in every element from the same template. Okay, so now you have this calculation. The next thing you might want to do is every time there's a deviation that's greater than 1% from this average, you are going to want to know, because this is an important event to you. So I have an exhaust temperature difference in percent. If it's greater than 1, currently it's false. If it's greater than 1 for 5 minutes, I want to know. I want the system to create an event frame for me. So as simple as that, what we have done is tell the system every time one of my measurements is greater than the average by more than 1%, I want to know. And as simple as that, you have created that event generation analysis. Now, you have 2 gas turbines. Each gas turbine uses fuel. You may want to do some roll-up of all the fuel gas flow from your gas turbine, and you want a sum of it, and you want to store the result of this roll-up into an attribute, which happens to be a pipe point. So with that, what this example has shown is that every time I get a new value in my gas fuel flow attribute, or that particular pipe point, this summation would trigger, and the results will get written to a pipe point. So as you can see, we've put in a lot of effort to make this configuration experience very rich, targeting the usage scenario that I described to you earlier. What you've seen is something that we've taken 12 to 18 months to build. And the feedback that we've gotten from our users so far is that previously, any sort of calculations that are done in the Pi server oftentimes would require 3 people. Obviously, the user who required that calculation, some sort of a Pi administrator to make sure that that all the resources are in place, all the required inputs are in place, and so on. But oftentimes, a developer may be needed because some of the calculations are just simply too difficult for the users or the Pi administrator to do, because the Pi administrator may not be a process expertise. And this really slows down the time that it takes for the user to start getting value from the calculations that he wants to perform. Now, with the new calculation engine in place in Pi Server 2014, many of our customers see a diminished role for the Pi developer because things are just so much easier and so much higher performing. As you saw, it's easy for a user to configure and test and validate the calculations himself. And all he needs is a final verification from the Pi administrator that all the data is in place and that the system is set up to allow him to create these calculations. And with the use of templates, whatever the user does, if he does it at a template level, they're not lost. because changes to analyses at the template level are propagated to all instances from that template. Now, what you saw, the new analytics engine, has gone through a couple of key milestones. In April 2013, we provided a private community technology preview to a select group of customers. And then in September of 2013, last year, we had an open beta where we had more than 300 beta users. And finally, in April of this year, approximately 2 months ago, we released the new calculation engine along with a host slew of other enhancements as PyServer 2014. So the next question is, okay, PyServer 2014, this is something that you want to use, this is something that you want to evaluate, how do you get it? If you're a new customer, obviously you want to talk to your account manager, and once that, the software itself is a simple download and install. If you're an existing customer, again, simple download and install. It's an easy upgrade. We support upgrades from previous version as long as you're an existing customer with a current and valid Software Reliance Program, SRP. And if you are a new potential customer for OSIsoft and you want to learn a little bit more about what we have available to you, I encourage you to go to the OSIsoft Learning website, which is at learning.osisoft.com. And at this website, we provide a whole slew of videos and examples that can give you more information on OSIsoft software. With that, I want to thank you for participating. And we have a few minutes here to take questions. So the first question that we got is, does the analytics engine support importing calculations in PMML format? We do not have native support for importing from PMML format. However, support for third-party calculation modules, let's just put it that way, it's on the roadmap for a future release. For many of our customers, they already have standardized on a third-party calculation engine, and that's fine, there's nothing wrong with that. However, we see a benefit to provide a bridge or a connectivity way between the calculation engine in Pi, connecting to an external calculation module so that we can mix and match built-in calculation functions in Pi with external calculation modules. So that's on the roadmap, and it's shown, well, it might not be shown, but it's certainly something that we plan on doing in the near future. The next question we got is, in a validated world, how easy is the upgrade from 2012 to 2014? Well, in a validated world, I would assume that's pharmaceutical or something along that line. The software upgrade is natively supported in the installation kit. So basically, you just have to run the software kit, and it will detect that an existing version is there, and it will update the software. I'm not too familiar with what's needed to revalidate the system, but I can tell you that we have many pharmaceutical company customers who either have already done the upgrade or they plan on doing so. So I hope that answers your question. I got a question here from a participant. Okay, the question was, it is, in order to make use of the AF asset-based analytics, what is the requirement for the Pi server version? I presume you are asking about the data archive version. So the new analytics engine will support data archive back to version 34380. So that's, I believe, about 6 years old. Next question. What happens to my PyAce servers now that PyAce is integrated into the Pi server? Well, we continue to support the configuration that you have, so there's really no need for you to do anything. If you're happy with how the system is running for you today, continue doing so, and it is still a supported configuration. So like I said, if it's working well for you, there's nothing for you to do. Next question. Is there a list of the calculations built into Pi 2014? Yes, there is. If you contact tech support, they will be able to provide that list of functions for you. Alternatively, if you go to the OSIsoft Live Library website, I believe it's livelibrary.osisoft.com, we provide the documentation via the web, so you can also look up the list of functions that way.
So I'm just going to ask one more question because we got it on our earlier webinar and on here as well. There are people that have asked about waiting to update until the next version. Can you talk a little bit about that?
Yes. Okay. So a couple of things. Some of you may know that we have identified a few bugs in notification, primarily related to upgrading existing Pi notifications. So if you are in a Pi notifications upgrade scenario, I would urge you to hold off. We have a patch coming out in about 6 weeks' time. However, if you are a new user or if you're not a Pi notifications user currently, there's absolutely no reason for you to not install Pi Server 2014 as soon as you can. If you go to the Pi System Roadmap, which the URL I presented a little earlier, you will see that the next major version of the Pi server, we're looking at probably around end of the first quarter next year, 2015. That version of the Pi server 2015, the major feature is for the data archive to be able to store time series data with a future timestamp. That's a feature that many of our customers have asked for in order to do forecasting, and that will be natively supported in the next major version of the Pi server.
All right. Well, that's all we have time for today. If you have any other questions, you can always email us. And if you didn't get your question answered, we'll try and answer those directly with you after the webinar. And also, you'll receive the recording post-webinar in the next few days, so you can re-listen and share with your colleagues. And also, you can visit our website for future events, seminars, and webinars, including our users conference in Lisbon this fall. So thank you again for joining. Please enjoy the rest of your week, and we will see you for the next one.